All right, this is a section on hypothesis testing. I have an assistant today, my cat Diego. So I'm going to make a ridiculous claim. I can guess exactly what you're thinking. Can we test that claim? Well, I've devised a test of that claim. What we're going to do is we're going to have my assistant pull cards from a card deck, and I will be blindfolded, and I will try to guess what color the card is, red or black. And then he'll tell you how many I got right. So if I know what you're thinking, I should know if you drew red or black, right? So one thing to think about here is how many would I have to get correct over 4 tries to make you believe me? Better yet, how many would I have to get correct for you to be suspicious that I wasn't just guessing? All right, I give you my son, Ernesto, who will be drawing cards while I am blindfolded. Am I blindfolded?
Yes, with a mask. How many do I take?
4 for the first one. So you let me know when you pull each card. And show it to the screen. Just tell me when you're ready.
Okay, no.
Okay, first card is a red, and then write down if it's right. No, you have to show it to the screen.
Okay.
So first card is red. Second card is black. Third card is red. And the fourth card is red. Ernesto, how many did I get right?
You got 1.
I got 1 right. All right, so let's talk a little bit about what we would expect under different situations. So we can actually detail how likely I am to get a different number. I'm sorry, I'm having a little problem with my. Let me reshare that. All right, so I got 1 correct. So obviously that's not really good evidence that I could guess what Ernesto was thinking. But we can actually figure out what sort of outcomes we can expect under a condition like under situations like this if we're just guessing. One thing we can do is we can see all the different combinations of things that can happen. For example, if I were to get everything wrong, there's only one way you can do that. You can guess wrong on every one of the guesses. Only one way to do that out of 16 total possible combinations of things. So that would happen about 6% of the time. We could say that the probability for getting 0 right, therefore, is about 0.06. Getting 1 correct, that's not particularly uncommon. In fact, the probability is about 25%. Getting 2 correct, that's the most common outcome. In fact, if I asked how many you expect if I was guessing, 2 would probably be the number that would come up the most, and that's about 38%. And then similarly for 3 correct and 4 correct, they look like 0 and 1, 25% and about 6%. Now, and again, just going over all the different ways to get 3 correct versus 4 correct and so on. Now, interestingly, if you turn your head upside down, this looks actually just like a normal distribution. In fact, we can use normal distribution properties in this exact same way. We can also think of this in terms of mean values, where 0 would be wrong and 1 was right. So getting all 4 correct would yield a mean of 1, whereas getting 1 correct, a mean of 0.25. So why are we bothering converting these to means? Well, in the next section, we're going to use means and standard deviation to calculate probability, and that's where things get really cool. And you can see the different mean values and their probabilities here. And this is actually just a very simple sampling distribution. And note that the shape of it, it's already starting to look like a normal distribution. And we'll see as we get bigger and bigger samples, it'll look more and more like a normal distribution. So next up, we're going to do 10 guesses. Ernesto, you're on. 10. Yeah.
What? 10 what?
10 cards, write down how many I get right. And you just give me some sort of signal when you're ready.
But you can't see.
You could give me a verbal signal.
Okay.
Ready?
Yes.
Okay. Black,
Okay.
red, red, black, black, red, 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 black, and red.
Okay.
How many did I get right?
Like 6.
6 correct. 6 correct. All right, so I got 6 correct. So how many do I actually need to get correct for you to believe that I can read minds? 6, 7, 8? What's the criteria? Well, we'll discuss how we can set a criteria. In fact, in psychology and in most statistical fields, we have a set criteria which is somewhat arbitrary, but it's useful to have that so that everybody's using the same criteria. Interestingly, with 10 cards, there's 1,024 possible different outcomes that happen, and we'll take a look at all of those different outcomes in a sec. So this is the number that we would expect if I was guessing with 10 guesses. It's the percentage correct that's listed here. You can see that getting 5 right, half and half, is the most common outcome, but almost equally as common are getting 4 and 6 correct, getting about that'll happen about 25 to about 20% of the time. 7 correct, that happens about 12% of the time. So starting to get a little bit less likely. Was getting 7 correct evidence that I'm not guessing? Well, who knows? 8 correct, well, that happens less than 5% of the time. 9 correct, 10 correct, there we're starting to get some pretty anomalous results. Getting 9 or 10 correct would happen very rarely, maybe about 1% of the time. But still, the question remains, what proportion correct would I need to get in order for you to say, okay, there's something going on here, you're not guessing? And again, this can be expressed in terms of mean values as well. You can see the different mean values. And in the next section, we'll see how we can start to apply this to some of what are called the concepts of null hypothesis significance testing, one of probably the most important concepts that we discuss in this class.